Okay, so this is what we learned in the last lesson. We're solving exponential equations, and we're going to do so by making the bases the same. So here, my base is 5, and it's raised to the power of n plus 10. How can I rewrite 25 so that my base is 5? Yep, we're going to put a squared here. 5 squared is still 25. So we didn't change the value, we just changed the format. Okay, now my bases are the same. So now we're just going to go ahead and solve what's left over. We have n plus 10 equals 2. What is n equal to? -8. So that is our answer here. Okay, now we need to rewrite the bases over here. We have to change both of them. So how did you guys rewrite the 9? 3 squared. And how did you guys write the 27? 3 cubed. Now, the exponents are going to stay the same. This is a plus 2, and this is 4a minus 2. Okay, your bases are the same. What is left over is 2 times a is 2a. 2 times 2 is 4. 3 times 4a is 12a. 3 times -2 is -6. All right, so guys, you're going to go ahead and finish this. We're going to get a equals something. Okay, I'm going to pause here. This is what we learned the other day. What we're going to see today is what if a common base is not possible? Okay, these are the steps that we're going to follow. First, we're going to isolate the exponential expression, and then we're going to take the log of both sides. So let's just look at this. Let's look at an example. Notice, guys, 2 to any power will not get you 61. Okay, so this is where we cannot get the same base. When you cannot get the same base, we're going to take the log of both sides. So, guys, copy this down. What's my base here? Yep, the base is 2. So I'm going to do the log with a base 2 on both sides. Logs and exponential functions are inverses of each other. So what happens is log with the base 2 will cancel out with an exponential that has a base of 2. Those canceled out. So what is left over is x equals log base 2 of 61. And this you can type into your calculator. Okay, so when we put it into the calculator, we got x is 5.93. Let's do another example. Okay, so here, what is my base? Yes, the base is 8. I'm going to write that up here. The base is 8. That means I'm going to take log with the base 8 and log with the base 8. Log base 8 and an exponential with base 8 cancel out. So what I am left with is m minus 7 equals log base 8 of 92. We're not quite done yet. What do I need to do to get m by itself? Yep, so we're going to add 7. So my answer is m is log base 8 of 92 plus 7. Now, a big mistake that I see a lot of people make is that they'll combine this and say it's log base 8 of 99. This is incorrect, okay? This is not right. Because what we're doing is we're taking the log of the number 92 and then we're adding 7 to it, okay? So put this in parentheses if that helps you. We do not combine 92 and 7. So what did you guys get? M is what? $9.17. Is that what everyone got? Nice. Okay. Let's move on to a harder one. Okay, so what we have to do first is isolate the exponential part. This is the base with the exponent. So we need this part by itself. So if I want that part by itself, what do I need to do first? Yes, you always start with addition and subtraction first. So we're going to add 2. we are left with 6 times 16 to the power of 7y plus 2 equals 84. Now what do I do to both sides? Yes, now comes the division. So we're going to divide by 6. Okay, and what's 84 divided by 6? 14, thank you. Okay, so guys, we said our base is 16. Since our base is 16, we're going to do log base 16 and log base 16 on both sides. This will cancel out. Now we have 7y plus 2 is log base 16 of 14. Okay, now we need to solve for y. What should I do? Yes, we're going to subtract 2. This does not become 12. This stays separate. This is log 16 of 14 minus 2. Then what do I do? Yes, then we're going to divide both sides by 7. So you're going to type this into the calculator. And let me know what you get. Y is equal to what? Negative 0.15. Thank you. So our first step is what? Divide by 4. Divide by 4. So we are left with 0.2 e to the negative 2x equals 16 divided by 4 is 4. Now what? Okay, let's just continue. So divide by 0.2, yeah? What I really wanted to write, guys, was 4 plus 0.2 e to the negative 2x equals 16. We're still solving it correctly, but you would have subtracted 4 first, right? If it was written like this, and then it would be 0.2 e to the negative 2x equals 16 minus 4 is 12. And then here we would have divided by 0.2. 0.2. We get e to the negative 2x equals, what is this? 12 divided by 0.2. We can do both. We can do both problems. We get e to the negative 2x equals 60 over here. Okay, now guys, my base is e. Do you guys know what we're going to use for an e?
2.718.
We're going to use ln of both sides. Yes. So this cancels out. And we're left with negative 2x equals ln of 60. Now what do I do to both sides? Divide by negative 2. So guys, this is what you would type into the calculator to solve this problem. Now let's come over here if you're interested. E to the negative 2x. What's 4 divided by 0.2? 20. And then you would take the ln of both sides. That cancels. We get negative 2x equals ln of 20. Divide by negative 2. And this is what you would type into your calculator. So I gave y'all 2 different practice problems with the e in it. And can y'all tell me what y'all got for your answer? For which one? Okay, this is negative 1. Negative 1.5. Thank you. And what y'all get for this one over here? Negative 2.05. Nice. All right.